Okay. So, now in this you have heard about the different kinds of microphone, their directivity pattern, their frequency response and their sensitivity. Now, in these lectures we details investigate what do you mean by sensitivity of a microphone, how the microphone sensitivity is desired or defined or how measured, you can say, or determined, and then we will discuss about what will happen if a microphone is connected to the preamplifier and in which condition it will be deliver the maximum power, and what is the electronically standard sensitivity defined by Electronic Association in Electronic Industry Association EIA. So, as per the EIA definition, the sensitivity of a microphone is defined as that how the voltage produced by the microphone for a given 1 Pascal sound pressure is called 0 dB voltage sensitivity of the microphone. What is the meaning of that? That suppose this is my microphone, I will say the sensitivity of the microphone is 0 dB if I expose this microphone to a 1 Pascal sound pressure and if it is produce 1 volt output at open circuit condition. Okay. So, open circuit voltage 0 dB means, so sensitivity is 0 dB of a microphone means if I produce a 1 Pascal sound pressure at open circuit condition of the microphone, if it is produce 1 volt output, then I call sensitivity of the microphone is 0 dB. Similarly, power, it may be voltage sensitivity, it may be a power sensitivity. What is the power sensitivity? Maximum power output of a microphone will shed 0 dB or 0 dB power output of a microphone is defined as if a microphone is exposed to a 1 Pascal sound pressure, if it is deliver 1 milliwatt power, then we said the power sensitivity of the microphone is 0 dB. So, in the specification of the microphone both can be written or one can be written. The voltage sensitivity of the microphone 1 Pascal pressure 1 volt, power sensitivity of the microphone 1 milliwatt power for a 1 Pascal pressure. Okay. Now, if I say this is 1 Pascal pressure is 0 dB, if the sensitivity of the microphone is 0 dB, then it is produced by 1 Pascal pressure. Now, if I say if I connect this microphone in or if I expose this microphone in a threshold of hearing SPL at threshold of hearing which is 20 micropascal in air, threshold of hearing 20 micropascal in the reference point, then how much voltage or what should be the sensitivity of that microphone at that pressure, or I can say what should be the voltage output of the microphone in dB. Okay. So, I say SB is equal to nothing but a 20 log E0, the voltage produced at the output of the open circuit condition of the microphone. Now, if I say if E0 is equal to 1 volt at 1 Pascal pressure, then SB is equal to 0. Now, if I say same microphone placed in a sound pressure level SPL where it is just threshold of hearing, then what is the sound pressure, what is the dB in 1 Pascal? So, 1 Pascal is equal to 20 log 1 Pascal divided by 20 micropascal. So, 1 Pascal SPL, 1 Pascal SPL if I express in dB, what is the dB? It is almost 94 dB, because it is 20 into 10 to the power minus 3. If you calculate that mathematics, it will come almost 94 dB. Okay. If it is 94 dB, so 1 Pascal sound pressure in dB, it is 94 dB. Okay. Now, in 1 Pascal it is produced E0 voltage. So, if I expose in minus 94 dB, is the threshold of hearing required to 1 Pascal. So, 1 Pascal is 94 dB. That means, if I expose the microphone in SPL 0 dB, that means as threshold of hearing, so pressure is dropped by 94 dB. So, SB will be SB minus 94 dB. So, it is 0 minus 94 dB is equal to nothing but a minus 94 dB. So, same microphone, if the sensitivity of the microphone is 0 dB, then the microphone sensitivity at threshold of hearing, as if it is nothing but a minus 94 dB. Okay. So, how much voltage it will be produced? If it is 1 volt, E0 is 1 volt means 0 dB. So, I can say that the E0 is nothing but a, what is E0? Is 10 to the power SV by 20. Okay. Now, SB is minus 94 divided by 20 into 10 to the power. So, I can get that voltage, that voltage I will get at the output of the microphone. Okay. Now, how do you measure that microphone sensitivity? How do you measure the microphone sensitivity? So, microphone sensitivity is measured in a condition. What is the condition? Let us see the setup. This is the setup. What is the setup? I require a pink noise source, which is the electrical signal source, and pass through a filter, go to a power amplifier, which amplify that signal and connected to a loudspeaker, and loudspeaker produce the sound. Let us explain one by one. Why the pink noise source? Suppose I want to test this microphone. What is required? I have to expose this microphone in a sound pressure level. Now, you know the sensitivity of the microphone is frequency dependent, but for a particular frequency range, I can make that microphone frequency independent, that we discussed in the first lecture. So, now, if I expose this microphone in a particular sound field, okay, so I have to produce that sound field by some loudspeaker. So, that is why this is loudspeaker. Okay. And then to produce the sound, I require a power amplifier, and power amplifier required a desired acoustic signal. What is the desired acoustic signal? I generate the desired acoustic signal of a particular frequency range by this filter, and input of the filter is a pink noise source. That means, all I apply a input to the filter, all frequency with the same power, same amplitude power amplitude, then pass through a filter for a particular band. So, if I say my filter is 250 hertz to 5 kilohertz, which generally does in microphone 5 kilohertz, then the acoustic signal produced by the loudspeaker is nothing but a acoustic signal of the frequency 250 hertz to 5 kilohertz. Okay. So, this filter has an upper cutoff frequency 5 kilohertz, lower cutoff frequency 250 hertz. Okay. Then this sound is propagated in the air. Let us, there is no disturbance of the environment. There is nothing, no disturbance of the environment, and this is pure pressure field. Pure pressure field. There is no free field. It is there is no reverberation. It is not free field. It is not, I can say it is not reverberant field. So, it is a pure pressure field. If it is pure pressure field, then what will happen? Once the sound is propagated, the inverse square law will be applied, the pressure will be dropped. Okay. Now, after certain distance, let us 1.5 meters from the loudspeaker, 1.5 to 2 meters from the loudspeaker, I put a sound level meter. What is sound level meter? SLM. Sound level meter measure the sound pressure level in dB. That means, with respect to threshold of hearing, in dB it is measured. So, what is 1 Pascal should be the reading? 94 dB with respect to threshold of hearing. So, if it is, I put the sound level meter and I increase the gain of the amplifier, still the reading of the meter is in not 94 dB. So, once the meter reading is 94 dB, I fix the gain, and the continuously sound is produced at 94 dB SPL at this point. Okay. So, now I reach the 94 dB SPL. Once I reach the 94 dB SPL, I remove the sound level meter and put a test microphone there. Okay. So, I put the microphone there, this is the microphone, and two electrical end of the microphone connected to a microvolt meter, which is microvolt meter. So, the reading of the microvolt meter, if it is E0 volt, then what is the sensitivity of the microphone? 90. So, 1 Pascal pressure produced voltage is the 0 dB. So, I can say SV is equal to 20 log E0. That is sensitivity. So, that way the sensitivity of the microphone is measured. I can measure the sensitivity of the microphone. Okay. Now, let us one condition that I have taken a microphone in here, and the data sheet the microphone sensitivity is written as SV. Okay. Now, instead of 94 dB SPL, I measure this point, the sound pressure level is LP. Now, if I expose this microphone in a LP sound pressure level, how much electrical voltage should it produce in the two end? Okay, understand? So, I said that at 1 Pascal sound pressure, if it is SV, that means 1 Pascal means 94 dB sound pressure. So, if it is LP in dB, LP is in dB. So, if it is respect to 1 Pascal sound pressure, effective LP is LP minus 94 dB, because I at least 94 dB, it is SV. So, at LP it should be LP minus 94 dB. Okay. So, output in dB, sensitivity of the microphone at LP is SV minus 94 or LV plus LP minus 94. So, this will be 20 log E0, the output voltage produced by the microphone 20 log E0. So, I can say E0 is nothing but a 10 to the power SV plus LP minus 94 divided by 20. Okay or not? See that? I am not going to the slides. Or similarly, if I said, if the microphone, I put a microphone, I do not know the sensitivity of the microphone, I put the microphone in LP sound pressure level, what should be the sensitivity of the microphone? Then in that case, I know E0, I know LP, and then I have to calculate SV in dB. Or other way, if I know the sensitivity, I know sensitivity, then I have to calculate E0. I can calculate E0 very easily. Okay. Now, let us look at this problem. A microphone, if a microphone is now exposed to an acoustic level of 100 dB rather than the 94 dB, then the output circuit, open circuit voltage should be E0 should be LP is 100 dB. So, it is, if it is microphone is minus 60 dB sensitivity, SB is minus 60 dB sensitivity, expose the microphone in a LP sound pressure level which is 100 dB. Okay. So, minus 60 plus 100 minus 94 divided by 20, 10 to the power. So, it is now E0 is nothing but a 10 to the power, how much will come? Minus 60. So, 10 to the power 40 minus 94 divided by 20. So, it is 10 to the power minus 4 5 divided by 20. Okay. So, this will equivalent to let us 0.002 volt. Now, we have to justify why we have take the sensitivity in open circuit voltage. We said that sensitivity is measured in term of open circuit voltage. Why I have to justify why I take the open circuit voltage? Why not it is a closed circuit? When the microphone is connected to the amplifier, that time we take the measure of the voltage. So, why it is? Now, if you see, if a microphone, I take a, I am not seeing the, I am not reading the slides. Let us understand that things. Suppose this is a microphone, okay, and these are the two electrical terminal. So, the if the microphone is connected to a, this is the preamplifier 2 terminal. If the microphone is connected to the preamplifier, then what will happen? There will be a output resistance of the microphone will be put across the parallel of the input. So, it is the R in is the input resistance of the preamplifier, R 0 is the resistive component of the microphone, resistive component of the microphone. If I say the R 0, if I connect this microphone with the amplifier in this condition, then if it is microphone is produced at E 0 voltage, then once R 0 is equal to R in, what will happen? The effective resistance between these two terminal will come R 0 by 2, because two same resistance in parallel will reduce by half, that is one equivalent resistance is 1 by R E is equal to 1 by R 0 plus 1 by R 0. So, it is nothing but a R E is nothing but a R 0 by 2. So, effect once the resistance is dropped, then in there E 0 will be E 0 by 2. Okay. But if R in is much greater than R 0, that means that if R in is very high, then 1 by R E is nothing but a 1 by R 0 plus 1 by R in. So, R E is nothing but a R 0 R in divided by R 0 plus R in. Now, if R 0 is much less than R in, then I can neglect this R 0 and it will equivalently it will come to R 0 value. Okay. So, if it is R 0, then the across this terminal the voltage will be E 0 in case of R in is much greater than R 0. So, I do not want when I measure the sensitivity, once I load it, then the voltage is dropped. So, what I want? I measure the voltage using a microvoltmeter. So, I want the input voltage, input resistance of the microvoltmeter should be sufficiently large, so that once I connect the microvoltmeter, the developed voltage should not be dropped. Okay. If R in is sufficiently high, what is the meaning of that R in is sufficiently high? That is nothing but a open circuit voltage. That means as if there is no load across the two terminal of the microphone. So, load is only R 0, the output resistance of the R 0. So, there is no extra load is added on that R 0. Okay. So, that is why we take the meter to take the reading of the sensitivity at open, we call or we can say rather define the sensitivity in term of open circuit voltage. Open circuit voltage. Generally, if you see usually R 0 value for a microphone is 250 ohms to 150 ohms to 250 ohms, and we take R in which is 10 times greater than the R 0. So, if it is 250 ohms, it will be 2.5 kilo ohms, greater than the 2.5 kilo ohms. So, we take 10 times, if it is 10 times larger, then almost the voltage R 0 does not change if I connect to the preamplifier or microvoltmeter. Okay. That is why we say the sensitivity of the microphone has to be measured in term of open circuit condition. So, it is not practically open circuit. So, that we are when we measure that open circuit voltage, the input impedance of the measurement instrument should be very high. Okay. Then there is another condition is called when a microphone is operate in an open circuit condition, the overall SNR can be improved by 3 dB compared to the situation when it is connected in impedance match condition. That I will answer, few slides will answer these issues. Another issue is there is a voltage sensitivity issue and there is a power sensitivity issue. What is the power sensitivity of microphone? We define in the power sensitivity, the power sensitivity of microphone is power delivered by microphone in milliwatt with compared in a 1 Pascal pressure. So, what I say, if I expose a microphone in 1 Pascal pressure, the amount of power delivered by the microphone in milliwatt will be the sensitivity of the power sensitivity of microphone. So, it is 0 dB, it is not dB. If it is milliwatt, then it will call dBm. Power is in dBm. So, you already we have discussed what is dBm. It is nothing but a 10 log power divided by 10 to the power minus 3 power in power milliwatt with respect to milliwatt. So, if it is power is expected, if it is a microphone produce 10 watt, then it is 10 watt divided by 10 to the power minus 3, that dBm. So, power is in dBm, ratio of the power is in dBm. So, 0 dB sensitivity of 0 power sensitivity 0 dB, that means 1 milliwatt produced by 1 Pascal. Okay. Now, we go for the power. How the microphone will deliver the power? How the microphone will deliver the power? So, let us start with a fresh page, that I have a microphone, and the two electrical terminal, it is here, and it is connected to a preamplifier. This is the preamplifier, and we connect it. So, output impedance of the microphone is R0 and input impedance of the preamplifier is Rin. Okay. So, if E0 is the voltage sensitivity of the microphone, E0 voltage is produced by the microphone, then this E0 will be loaded here. Now, if you see, when R0 is equal to Rin, impedance match condition, then E0 will be dropped by half. Okay. So, power sensitivity is defined by AIP, available input power, AIP. When I express in dB, we said LAIP, available input power level. L means level. Once it is level, then AIP will be expressed in dBm, available input power level, AIP is defined as in dBm. So, if this is the condition, when R0 is equal to Rin, how much power will be delivered by the microphone to the preamplifier? So, E0 is open circuit voltage. So, once it is R0 is equal to Rin, then E0 will be dropped by half. Voltage across these two terminal is E0 by half. So, available input power, if I say AIP, not level, I said available input power. If it is level, then it will be dBm. Available input power is E0 by 2 voltage into power is nothing but a V into I. What is I? E0 by 2 into 1 by R, R0, V into I, V by R is the I. So, it is nothing but a E0 square by 4 R0. Now, what is E0? SB, if the voltage sensitivity microphone is SB, then 20 log E0 is SB. So, if it is 20 log E0 is SB, then E0 is nothing but a 10 to the power SB divided by 20. So, what is E0 square? Is nothing but a 10 to the power SB by 10 into 20 means 10. So, I can write it is nothing but a 10 to the power SB by 10 divided by 4 R0. Okay. Now, if I take, so available input power is 10 to the power SB by 10 divided by 4 R0, if it is microphone is connected in impedance match condition. Okay. Now, the LAIP, when I say that L level of available input power or power sensitivity of the, to determine the power sensitivity of the microphone, or LIP, what I have to take? I have to take milliwatt, because I said dBm is nothing but a watt divided by 10 minus 10 to the power 3. So, I have to divide AIP by 10 to the power minus 3 is equal to 1 by 10 to the power minus 3 into 10 to the power SB by 10 divided by 4 R0. Is okay? 4 R0. So, it is nothing but a 10 to the power 3 by 4 into 10 into SB by 10 into 1 by R0. Okay. So, what is LIP? LAIP label is nothing but a 10 log power divided by 10 to the power minus 3. So, this I have known, this part I have known, 10 by this part I have known. I have to then take the log and 10. So, if I say take the log in both side of this equation, what will come? Take the log in both side of this equation. So, log of AIP divided by 10 to the power minus 3 is equal to log of 10 to the power 3 plus log of minus 1 by 4 is minus. So, it is plus log of 1 by 4 plus log of 10 to the power SB by 10 plus log of 1 by R0. So, I can write log of 10 to the power 3 is 3 plus log of 1 by 4 is nothing but a minus 0.6 plus it is nothing but a SB by 10 and it is nothing but a minus log of R0. Okay. Now, if I multiply by 10 both side, then I get LAIP, available input power, LAIP. So, LAIP is equal to 10 log AIP divided by 10 to the power minus 3 in dBm. So, it is nothing but a 30 minus 6 plus SB minus 10 log R0 dBm. So, it is nothing but a 24 plus SB minus 10 log R0 dBm. Now, if I say the output R0 of a microphone is 200 ohms and SB of a microphone is minus 60 dB, then what should be the LIP? So, LAIP is nothing but a 24 minus 60 minus 10 log 200 dBm. So, it is nothing but a, if I said what is the value of 10 log 200, it is nothing but a 23. So, it is 24 minus 60 minus 23 dBm. So, it is nothing but a minus 59 dBm. Okay. So, LAIP you can calculate. Similarly, if I say GAIP, EIA specification of the power sensitivity in GAIP, it is written as GAIP. What is the GAIP? GAIP is nothing but a power sensitivity with respect to SPL, sound pressure level, reference sound pressure level, which is nothing but a with respect to 20 micropascal. Okay. So, instead of 1 Pascal, if I say 20 micropascal, then the 94 dB is the difference. 94 dB is the difference. So, I can write GAIP is nothing but a LAIP minus 94 dB. So, if I know LAIP, so what is LAIP? Is 24 plus SB minus 10 log R0 minus 94. So, it is nothing but a SB minus 70 minus 10 log R0. So, why I express in GAIP? Because if you see the GA, if I express it, since the SPL is lower by 94 dB, the LIP equation 10 will become lower by 94 dB, and we denote power sensitivity GIP because when we measured microphone, if we know the microphone GIP in some SPL, let us LP SPL, the GIP in L1P SPL will be just subtract the difference of the sound pressure level. Just subtract the difference of the sound pressure level. Suppose in 100 dB SPL, if GIP is given or the GIP given, if the microphone GIP know what should be the GIP at 100 dB SPL, I should just simply subtract that difference. So, it is 94 dB, so it is 100 dB. Okay. So, that is why we always express the power sensitivity in GAIP. Now, I come to the next condition. When a microphone is connected, then if the microphone, why that the questions which I have raised in here, when a microphone is operate in a open circuit condition, the overall SNR can be improved by 3 dB compared to the situation when R in and R 0. Okay. Now, if a microphone connected to a preamplifier, there will be a thermal noise. Any microphone, if it is connected to the preamplifier, there will be a thermal noise. What is thermal noise? Since microphone is, if it is resistance, suppose I have a resistance, and if I flow a current through the resistance, then a thermal noise will be produced. Average value of the thermal noise across the resistance may be 0, but the RMS value is not 0. So, thermal noise of a resistance can be expressed resistance through a Nyquist voltage source, that V, and resistance is R. Then the expression of the thermal noise V is nothing but a 4k T R B to the power half. This is the formula. What is K? K is the Boltzmann constant. What is T? Temperature in Kelvin. What is R? Is the resistance. What is B? Is the bandwidth. B is the bandwidth. If you see these slides, B is the RMS noise voltage, Boltzmann constant, absolute temperature, resistance, B is the bandwidth. So, the signal bandwidth is also effect on the how much noise voltage will be produced. Okay. Now, consider the case of a microphone. So, a microphone, microphone has R1 output resistance and has a Nyquist voltage source V1 for the thermal noise. Similarly, input resistance of the preamplifier has R2 and has a Nyquist voltage source V2 for the thermal noise. This is the condition. So, the thermal noise contributing to the amplifier, if V2 is not present, let us V2 is not present, then the thermal noise, the current flowing through these circuits, it is nothing but a V1 divided by R1 plus R2 when the V2 is shorted. Similarly, if I say this is I1 current flowing, what is I2 is nothing but a V2 by R1 plus R2. What is V1? If it is temperature of this resistance is T1 and temperature of resistance is T2, then V1 is nothing but a 4k T1 R1 B divided by R1 plus R2 root over. Okay. What is V2? 4k T2 R2 B, same bandwidth, root over of half by R1 plus R2. Okay. Now, how many power? Suppose this source is not there. So, it is power is P1 and P2. The noise power delivered from the microphone to preamplifier is P1, P2, and noise power delivered by the preamplifier to the microphone is P21. So, what is P1 to I1 square into R2? The current I1 current will be flowing through R2 and that noise will be that power will be delivered. So, it is nothing but a I1 square into R2. So, what is I1 square? Is nothing but a 4k T1 R1 B into R2 divided by R1 plus R2 whole square. Okay. What is P21? Is nothing but a I2 square by R1, I2 square into R1. So, I2, what is I2 square? 4k T1 R2 B into R1 divided by R1 plus R2 whole square. Okay. Now, if you see, what is the difference between the two expression? Two expression is only differ by T1 and T2. Sorry, it is T2, T1 by T2. If T1 is greater than T2, then the power will be transformed from T1 to T2. If it is T2 is greater than T1, then the power will be transformed from T1 to T2 is greater than T1, then power will be transformed for T2 to T1. Now, at equilibrium condition will be happen when T1 is equal to T2. Okay. Now, I have to calculate what is the effective noise voltage is acting in here. Effective noise voltage is acting in here across this terminal. So, effective noise voltage, how do you calculate? The noise voltage across the common terminal can be calculated by superposition of V1 and V2 superposition. So, voltage when both the source act simultaneously. So, how do you get the superposition? First, the V2 is not there, I calculate the voltage. V1 is not there, I calculate the voltage. Then do the superposition. But both the source is simultaneously is on. Then how do you obtain the appropriate combination? So, this is, in this case it should be quadratic sum rather than the linear sum, because I do not know the generated source are completely in random phase, two sources are completely in random phase. So, I do not know whether it will be linear superposition. So, instead of take the linear superposition, the effective voltage I can get by the quadratic superposition. So, square of the voltage will be added up. So, quadratic superposition V will be the square of the voltage added up. So, it is nothing but a I1 current flowing across the R2. So, I1 R2 is the voltage square plus I2 current flowing across the R1 whole square, then take the root over quadratic voltage sum. So, what is I1 is nothing but a V1 R2 divided by R1 plus R2, V1 square R2 square divided by R1 plus R2 whole square. It is nothing but a V2 by R1 plus R2. So, this is V2 square R1 square R1 plus R2 whole square. So, what is V1? V1 is nothing but a 4k root over of 4k T1 R1 B, and V2 is nothing but a root over of 4k T2 R2 B. So, I can put that value, then what will cut? Root over of V1 is 4k T1 R1 B into R2 square divided by R1 plus R2 whole square plus 4k T2 R2 B divided by R1 plus R2 whole square into R1 square. So, now if I take, it will be, if I simplify it, then it will be root over of 4k B R1 R2, it is T1 R2 plus T2 R1 divided by R1 plus R2 whole square. Okay. Now, if it is, this is the case, then if T1 and T2 is equal and equal to T, then I can say this is reduced to 4k B R1 R2 T divided by R1 plus R2 root, R1 plus R2 root, okay or not? Okay. So, if now I put the condition, now at the, let the both the things are have the same temperature. Now, if so, voltage is in that case the V is equal to root over of 4 KB R1 R2 T divided by R1 plus R2. If R1 is much less, R2 is much greater than R1. What is the meaning? The input impedance of the preamplifier is much greater than the output impedance of the microphone. Then V will be R1, R2 is much greater than R1. So, I can, this R1 can be cancelled. So, it is root over of 4 KB R1 into T. Okay. Now, if R1 is equal to R2, R1 is equal to R2, then V will be root over of 4 KB R1 into T divided by 2 R1. So, R1 is cancelled. So, it is nothing but a 1 by root 2 into, if it is V dashed, 1 by root 2 into V dash. So, if it is impedance match condition, then thermal noise voltage is reduced by 3 dB. At the same time, if it is impedance match condition, then available input power is E0 is by half, so it will be reduced by how much? 6 dB. So, overall SNR, if it is impedance match condition, then I get 3 dB less thermal noise, but I lose 6 dB due to the impedance match available input power. So, ultimately gain 3 dB is here. If it is not impedance, if R1 is greater than R2, I get 3 dB more noise power, but at least this 6 dB down will be not there. So, I can say that in case of this case, so I can, this statement I can say it is true. When a microphone is operated in open circuit condition, the overall SNR can be improved by 3 dB compared to impedance match condition. It is proved. Now, suppose there is another situation, you will heard about that, when the microphone is connected to the amplifier, we will concern about that overall noise figure. Means microphone connected to the amplifier, and output of the amplifier if produce noise, that we have a system called overall noise figure. So, I have to calculate the overall noise figure. Instead of thermal noise, there is other noise also, short noise, flicker noise, partition noise, all kinds of noise. There may be a line disturbance noise, all kinds of noise will be there. Now, if I consider only thermal noise, then what is SNRS? What do you mean by SNRS? SNR of the source. So, Vs is the source sensitivity of the source Vs, and divided by the thermal noise 4 kT Rs into B. T is the Kelvin temperature, Rs is the resistance of the microphone, B is the bandwidth of the microphone. This is SNRS. Now, in case of Rin is greater than Rs. Okay. Now, what is SNRA? Is nothing but a VOS input power to the SNR, input power to the amplifier, output power of the amplifier divided by input power. So, VOS square divided by VO on square. What is VOS? VOS nothing but a square by signal square. So, if the gain of the amplifier is S, then the output of the amplifier will be divided by the gain. So, the power is nothing but a square. SNR, if it is power, then it will be voltage square. So, square OS square by V1 square. What is VO1 square? The total output power is nothing but a, this is the output power for the signal, output power of the noise 4 kT RSB, which is the thermal noise power, plus VNA power, which is the noise for the amplifier, noise produced by the amplifier. So, SNRA is nothing but a VOS square by VO on square is nothing but a square V s square divided by 4 k T R s B plus V n square. Okay. V n is the mean square noise voltage at the amplifier output contributed by the amplifier. Now, what is the figure of merit F is called SNRS by SNRA. SNRS by SNRA. So, I can write F is nothing but I know that VNA is nothing but this one V minimum, and I know that V minimum is this one. So, I can write this expression like this way. So, noise figure of the amplifier is in always said the noise figure, we said the noise figure of the amplifier NF is nothing but a 10 log noise figure of the amplifier. So, what is 10 log F? 10 log SNRS divided by SNRA. So, it is nothing but a 10 log SNRS minus 10 log SNRA. Okay. Or 10 log SNRS is nothing but a 10 log SNRS plus noise figure, or SNRA is nothing but a 10 log SNRS minus NF. So, if I know the noise SNRS, microphone SNR if I know, and if I know the noise figure, I can calculate the amplifier SNR. Okay. So, you can solve this problem. I have a problem, I have given a microphone and given an amplifier specification. If a talker produce 80 dB near the microphone, find out the signal to noise ratio at amplifier output 20 degree centigrade in dB. Output at 20 degree centigrade in dB. So, use this equation and find out the amplifier output. Okay. Thank you.